All right, so this is a key to the in-class activity that you did or that you're supposed to have worked on during the last class period. So you want to graph this quadratic function, and to do that, we're going to first of all determine the vertex. So I kind of wrote out in steps what you're going to do. So so notice that this equation is written in general form. It's not written in vertex form. So it's written in general form. So once it's written in general form, then there's a formula that you can use to find the vertex. So the vertex formula is this. So remember the vertex is HK, and H, to find the coordinate of H, to find the x coordinate of your vertex, it's going to be negative b divided by 2a. And then once you find your x coordinate to find k, then you're going to take h and substitute it back into your function to find k, which remember h is this, so some textbooks will write it as f of negative b divided by 2a. Okay, so here's how it works. So you got to first of all determine a, b, and c. So a is a coefficient of x squared, so that's 2. B is a coefficient of x, so that's a negative 12. And c is your constant. All right, so we got to show the work. You are expected to show the work with this. Let me go ahead and use another sheet of paper. So there's going to be b. B is your vertex. So there's the, a rather. So here's the work for your vertex. So we got to find the x coordinate of your vertex. So let's find h. So h is negative b divided by 2a. B in this case is a negative 12. The opposite of negative 12 is a positive 12. Divided by 2 times a is 2. So that's 12 divided by 4, which is 3. So far, my vertex has x coordinate of 3. To find the y coordinate, you're going to find f of 3. So k then will be f of 3. And so then I go to my function f, and wherever we see the variable x, I substitute 3. So I get 2 times 3 squared minus 12 times 3 plus 10. Order of operations, you square first. 3 squared is 9. 9 times 2 is 18. So you had 18. Negative 12 times 3 is a negative 36, and then plus 10. 18 subtract 36 is a negative 18. Negative 18 plus 10 is a negative 8. So I get 3, negative 8. So there's your vertex. Okay? So that's your first one. So you found the vertex. You're done. There's the work. I need to show the work. All right, so your vertex is 3, negative 8. Okay, now you got to find your axis of symmetry. Now you got to be careful, and I need for you to remember this. The if oh, and by the way, let us before we find the axis of symmetry, let's do this so I can draw it here. So does the function open up or down? Well, remember, the parabola opens up or down is based on the coefficient of x squared. So x squared, the coefficient is a positive 2. Since this is positive, your parabola is going to open up. So do something like this, right? It's going to open up. Okay, so I'm going to put right here, it's going to open up. Just make sure you know why, because the coefficient of x squared is positive. If this was a negative 2x squared, it would open down. Okay, now let's go back to part B. Remember the axis of symmetry always goes through the vertex. Always goes through the vertex. And this axis of symmetry is a vertical line. And in class, we spent some time talking about how to name a vertical line. So to name a vertical line, it's always going to be x equal. X equal is the equation of a vertical line. And basically, it's going to be whatever the x coordinate is of your vertex. So the axis of symmetry is always going to be x equal h, whatever h is. So in this case, my x coordinate is -3. So that's going to be my axis of symmetry. So don't put -3. We talked about this in class. You got to name the axis of symmetry using the correct mathematical naming for it. It's a vertical line. So you have to say x equal. So the answer should be x equal -3, not -3. If you put -3, you're not going to get all your points. Okay, now we got to determine the y-intercept. Okay, one thing you got to remember is this. And let me go ahead and use this right here. Regardless, regardless of what the parabola looks like, whether it does this, whether it does this, whatever it may be, right? It's always going to have a y-intercept. At some point, your graph is going to cross the y-axis. It's always going to have a y-intercept. And the reason it's going to have a y-intercept is because, and I don't know if, yeah, I have it down here, because the domain of all polynomial functions, and this is a polynomial function, right? This is what it looks like. A polynomial function is a smooth curve. This one happens to be quadratic, but it's a smooth curve like this. And the domain is all real numbers. All real numbers, regardless of what the polynomial function looks like. So in other words, it could do this, it could look something like this, right? So you could have a polynomial function that looks like this, and notice that it's going to have a y-intercept. So a polynomial function always has a y-intercept because the domain of a polynomial function is always going to be all real numbers. And you denote all real numbers in interval notation as -infinity to infinity. All right? Okay, now, so we know it's going to have a y-intercept. Well, remember, to find the y-intercept, and this is going to be d, to find the y-intercept, you're going to let x equals 0. But we talked about this before, didn't we? We said that the general form of a quadratic equation looks like this: f of x equal ax squared plus bx plus c. So if I let x equal 0, then this will be 0, this will be 0, and all you're left with is c in it. So we found out that the y-intercept is always this constant. So if you look at this right here, my constant is 10. So my y-intercept is just 10. And if you want to put it as an ordered pair, you can. It's actually 0, 10. Okay? But that's how you find the y-intercept. You let x equal 0, but since this is in general form, it's just that constant. All right, now we got to determine the x-intercepts. Now, one thing you have to remember is that a polynomial function, even though a polynomial function always has a y-intercept because the domain's all real numbers, it may not always have a x-intercept. For example, you could have a polynomial function that looks like this. Notice it never crosses the x-axis. You could have a parabola, a quadratic function that does this. It doesn't cross the x-axis, so it's not going to have any x-intercepts. Okay? It's always going to have a y-intercept, but not an x-intercept. So, before you do E, always ask yourself, first of all, does it have an x-intercept? All right, well, to determine that, you think about your you think about your vertex. My vertex is -3, -8. So that's in the third quadrant. It also goes up. So since it goes up, notice it has 2 x-intercepts. So then I can find them. And I did tell you to round the nearest tenth. So let's go ahead and do the work. It does say show the work. All right. So to find the x-intercepts, remember, to find the x-intercept, you're going to let y equals 0. So if I let y equals 0, that means that this equals 0, doesn't it? 2x squared minus 12x plus 10 equal 0. So to solve this quadratic equation, I'm going to use a quadratic formula. Oops, let me go ahead and redo this over. Quadratic formula. And let me do that here. This will be E. Find x-intercepts. All right, quadratic formula is the opposite of b, plus or minus the square root of b squared minus 4ac, all of that divided by 2a. So in this case, a is 2, b is negative 12, and c is 10. And I just want to show you something. So when I am solving this quadratic equation, knows there's an equal 0, right? I notice that all three terms here and even the other side are all divisible by 2. So if I wanted to, I could have, just to remind you, I could have divided both sides by 2. And if I divide both sides by 2, if I divide both sides by 2, 2x squared minus 12x plus 10 equals 0, kind of like this, I'm going to get x squared minus 6x plus 5 equals 0. And in this case, x is 1, b is negative 6, and c is 5. I could have found the x-intercepts using this equation instead of this one. All right, now, they would have had the same x-intercepts, but now you could try it. You could do this and then do this, and notice you'll get the same x-intercepts. Same x-intercepts. Okay, but most people did not recognize that, so let's just leave it like this. So we're going to say a is 2, b is negative 12, and c is 10, right? Okay, so let's substitute all that into the formula. So my x-intercepts will equal the opposite of b. b is negative 12. The opposite of negative 12 is 12. Plus or minus the square root of b squared, so that's negative 12 squared, minus 4 times a is 2, times c, which is 10. All of that is being divided by 2 times 2. 2 times a. So I get 12 plus or minus the square root of negative 12 squared is 144. A negative 2, negative 4 times 2 times 10, so that's negative 80, right? Or subtract 80 over 4. All right, and then using your calculator, if you have to, you're going to say 144 minus 80. 144 minus 80 will give you 64. Okay, and it turns out that 64 is a perfect square, meaning that I can rewrite this as 12 plus or minus 8 over 4. And so now I'm going to get rational numbers, rational solutions. I will end up with rational solutions instead of irrational solutions. So I'm going to say 12 plus 8 divided by 4, 12 minus 8 divided by 4. 12 plus 8 is 20. 20 divided by 4 is 5. 12 minus 8 is 4. 4 divided by 4 is 1. Now notice, even though I said round to the nearest tenth, that part was not necessary because these are rational numbers. So I'm going to leave them as such because, 5 is 5, right? 1 is 1. It's not like I'm saying, see, if this, what I mean by that is if this had been the square root of, let's say 17, then I would have needed to use a calculator. I would have had something like, let's say 2 plus the square root of 17, I'm making this up, over 3. We did this in class, so remember, if you do end up with an irrational number, then remember how to do that on your calculator. You're going to say 2 plus the square root of 17, close the parentheses, press equal now because that's the numerator. So there's your numerator. Then divide by 3, and then that's going to be approximately equal to the nearest tenth. You would say 2.0, which is 2, right? Okay. All right. Now that's what you would do if you did end up with irrational number, a square root. All right. So there's your 5 and 1. Now remember, we said this in class. We said once you find your x-intercepts, verify that those could possibly be correct. Verify that could be your x-intercepts. And here's what we said, right? We said this. If if this, if these are your x-intercepts right here, and this is your axis of symmetry, then 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 remember your axis of symmetry has um, HK as your coordinates. Then this is H right here, right? X equal H, right? So this segment right here, this is the middle of it. So we said that once you get to your x-intercepts, verify that those could possibly be correct. So you take your x-intercepts, add them up, and divide by 2 to see if you get the um, the x coordinate of your vertex. So watch. 5 plus 1 is 6. 6 divided by 3, I'm sorry, 6 divided by 2 is 3, and that's what we have. The x coordinate is 3. So always verify that you did not make a mistake here. I mean, you could have still made a mistake because these could have still added up and then divide by 2. You could have still gotten 3, but at least you could have checked to see if they could be correct. All right, because if they don't add up, if what you had here did not add up, divide by 2 and gotten you the x coordinate of your vertex, you did something wrong. These would not be correct, or this is not correct. All right, so that's E. So your x-intercepts work on next page. Next page. And so your x-intercepts are, and I didn't say how to write them as ordered pairs, so you're just going to say x-intercepts are 5 and 1. 5 and 1. All right, now, before we graph this, let's look at the graph again. So here's what I have. A rough sketch of this. So here's my vertex, 3, -8, right? I know it goes up. Now I know the domains are real numbers. Now the range I can find right away without even actually looking at a perfect graph. The range, you're going along the y-axis, aren't you? So I guess along the y-axis, I'm touching the graph here where where y is -8. So you're going from -8 all the way to infinity. So this will be -8 to infinity. So bracket -8 to infinity. All right, and then let's go ahead and graph this, and then we'll talk about this. Although it wasn't necessary to graph it, you could have answered this question right away just by looking at this again, right? So look, so here is my vertex, -3. Oops, sorry. 3, -8. You know, I've been drawing the vertex in the wrong quadrant. 3, -8 is here, but it didn't matter. You still got the same answer. But it's going to matter now because I'm not I've got to now find the intervals where the function is increasing or decreasing. So this is 3, -8, not -3, -8. 3, -8. All right. So as I go from left to right, my function here is decreasing, and then all of a sudden, at this axis of symmetry, my function's doing what? It is increasing. So decreasing, increasing. And so remember when filling in the blank for increasing, decreasing, you're looking at the part of the domain that corresponds to that. So this part corresponds to the decreasing, and this part corresponds to the increasing. So you're decreasing from -infinity all the way to this x coordinate, which is your axis of symmetry, which is at x equal 3. So you're going to say decreasing from -infinity to +3. I don't know why I want to keep saying -3. And then it's increasing from 3 to infinity. From 3 to infinity. And remember, whenever we talk about increase and decrease, it's always over an open interval. So that's why you see parentheses. So I think I answered all the parts here. Now we're going to graph. So let's look at the graph. All right, so let's see what we have. Okay, so the first thing I'm going to do is plot the vertex. The vertex is well, I'm not sure. Let me go back here. I have 3 negative 8, right? And then all of a sudden I have here negative 3 8. Let me make sure I know which one's correct. So, um, so it's 3 negative 8. So I made a mistake here, 3 negative 8. So that's why I was wondering, why do I keep going back to, remember I kept going back to putting it here, negative 3 negative 8. And what I was looking at was this, where I mistakenly put a negative 3. This should be a positive 3. So positive 3, negative 8, which makes this what? Positive 3, right? Okay. All right, so axis symmetry is x equals 3. All right, so let's go ahead and graph this. So my vertex is 3, negative 8. So 3, negative 8 is here, right? Here's my vertex. My Oh, and then I can go ahead and at this point draw my axis of symmetry to help me. Always draw that. Always draw the axis of symmetry. It does help you to draw a better graph. Um, you don't have to, but it does help. Then we found the x-intercepts. The x-intercepts are 5 and 1. So 5 and 1 right here. And we found the y-intercept, which is 10. And so that's right here. And then look, I want to remind you about something. So remember, once you find the y-intercept, you know another point on the other side. So this distance is 3 units, right? To the axis of symmetry. So therefore another point should be 3 units on this side. So look, 1, 2, 3, axis of symmetry, 1, 2, 3. So there's the other point. And then just do the best you can with drawing this. Make sure it looks like a parabola. Do the best you can. If you have to erase, erase it. Don't make it look like segments. Make it look like a parabola. All right, so if you make it look, just do the best you can. It's not doing. If you have to erase, erase. So something like this. See how I did this? And then over here, do the same thing. So do the best you can. Make it look symmetrical. Make it look symmetrical about the axis of symmetry. Do the best you can. Something like this. And then over here. Oops. All right. I could have done a little bit better. But something like that. Okay? Uh, and that's it. So there's your graph. See how it looks? So that's the graph. Let me go ahead and see if I can decrease the size without changing, without messing this up. We'll see. We'll see if it messes up. So let me see. Ooh, okay. So that's what your graph looks like. All right. So that was the in-class activity that you were supposed to have done. Look at the work. So quite a bit of work, right? Um, all right. So that's it. All right. Make sure you understand this. That being able to graph quadratic functions is important. All right. Good luck with this. It's not that bad. All of you should be able to do this.